Hello everybody, and I'm pleased to say it's finally time. The Amiga A600 that I lost in my house fire is finally going to get the resurrection it deserves. I'd never have known before, but soot is actually a greasy toxic mess and it clings to everything. I have to admit I'm a bit nervous about this video because I'm not sure how well this board will clean up. In fact, it looks a bit hopeless. Close-up inspection shows that this greasy grimy mess has penetrated every single crack on this motherboard. Even down to the ports all along the back. I mean, they're rusty, they're grimy, and I'd never be able to clean these manually, so I think we're really looking for a miracle here. But as we learned in our previous video, this Amiga tries to boot, so I think it's fair to give it a crack of the whip. So in my first ever ultrasonic clean adventure, we're going to see if we can recover this Amiga, and we're going to do it right now.
Mark fixes stuff. This video is sponsored by PCBWay. You can get an instant quote on a variety of services, or browse a library of talented makers' designs, add them to your cart, and have them delivered directly to your door.
So the first task was to remove the board from the lower case. And this is a task that's easier said than done. To get it out, I had to twist all the tabs and even flex the lower part of the case to liberate the board. But with a bit of wrestling, we managed to get it out. Victory! As we can see, it's in a right state, although surprisingly the underside of the board isn't too bad. There are some obvious signs where water has got inside the computer and sat inside the case next to the motherboard, but I don't think it's going to be that critical. As we remove the motherboard, we find the plastic insulation sheet and the shielding, and they're both in a really sorry state. I'm not really sure if we'll be able to save these, so we might need to find some alternatives. The shielding is showing a lot of rust, and the plastic insulation sheet has really absorbed all the soot. At this point, I have to say that this all really still smells terribly of smoke. We actually don't need this lower case because I have a plan with our very kind sponsors over at PCBWay, and I'm going to hide a clue about that somewhere in this video, so keep a lookout and watch till the very end. At this point, I'm just amazed that this was so close to the source of the fire. I mean, everything around it was decimated, but things collapsed on it and left it relatively unscathed. The EPROM that I was using for the kickstart has already been removed, so that should allow for more efficient cleaning underneath the socket on the board. And we'll also remove the lid from the modulator, and that should prevent any cleaning fluid from getting trapped inside. It's a bit rusted shut, so we'll have to force our way in. It's still shiny inside though, look. I think it's fair to assume that this is never going to be beautiful again, but let's just see what the ultrasonic cleaner can do for it. So we're ready to try the ultrasonic cleaner, but I have to admit I'm a little bit nervous because this Amiga A600, when it tried to boot, it struggled for life. So if this process kills it, my name will be mud. This cleaner is sold as a 22 litre model, which sounds really big, but in actual fact it's not as big as you'd think. Stop giggling at the back. When you measure the tank and calculate the volume, it's a little under 20.5 litres, and knowing the volume is really important. In order to avoid damage to our cleaner, we need to calculate how to fill it to 2/3 of its capacity with 1 part of this ultrasonic cleaning solution, mixing it with 10 parts of this pure distilled water. That's a lot of water. Using my Lizard Fixer's brain, I've worked out that we need about 12 litres of distilled water and 1.2 litres of the cleaning solution. So in goes the first 5 litres in its entirety, which is a bit ouchy because it's not really that cheap. Using distilled water is important though, because normal tap water contains minerals and elements that can end up staying on your board after washing. Distilled water has had these elements removed using an evaporative process, leaving it nice and clean for our cleaner. And in goes the second 5 litre container. I've literally had to save up to do this video. Totally worth it though. I ran down the shops and grabbed the first pair of jugs I saw. One's larger than the other, which is perfect for my use. So now we can measure a final 2 litres of pure distilled water. Lovely. But let's speed things up a bit. Markfix's stuff is driven by its generous patrons. If you'd like to become a patron and help enable more videos like this, then please visit patreon.com/Markfix's stuff. You can get ad-free early access to my videos and more. Ooh, a bit of a delayed drip there. Let's save this for later. I've certainly got enough stuff to clean. Although we calculated that we need 1.2 litres, I think I'm going to add 1.5 litres for a bit of extra oomph. And that's still within the guidelines specified by the cleaning solution. The eagle-eyed among you will notice that I'm not wearing gloves and this is running down my hands. It's caustic, so make sure that you wear gloves if you handle this stuff. Lesson learned. Using an appropriate cleaning solution is actually really important because it stops the molecules of the water clinging to each other and allows cavitation to happen more readily. As we add another ½ litre of the cleaning solution to the tank, we can see that surfactants have really affected the surface tension of the water, and the surface itself is visibly bubblier. I'd like to think that at 2/3 full it's no accident that our fluid is at the top of the basket, with the basket handles above the surface of the fluid, ready to grab. I should have said this at the beginning, but now and only now is the time that you should connect your cleaner to the power, because nobody likes to get electrocuted. Upon power on, the default temperature of 50 degrees is shown on the display, and it's easily changed by the up and down temperature buttons. And then we press the on-off button to start the heater. Heating the cleaning solution will allow cavitation to occur more easily. And cavitation is the magic behind ultrasonic cleaning. Reading the manual, it says that it can take about an hour to reach the desired operating temperature, so I sat and I watched. But I found that with the temperature set to 50 degrees it would hover around 48 degrees, so I increased the temperature to hopefully get us over the 50 degree mark. But 48 degrees is hot enough to start the degassing process, and degassing the solution is absolutely vital. Headphone warning in 5, 4, 3, 2, 1. Well, you can't say I didn't warn you. Simply running the cleaner for 10 minutes agitates any gases that are trapped within the fluid and drives them to the surface. If these gases were left in the fluid, they'd block the ultrasonic waves and really minimise any ultrasonic cleaning power. With our cleaner up to power, let's load up the victims. Well, I mean patients. I'm genuinely not sure about this. I also recovered this old smoke-coated Gotek board from the ruins of the house, so why not pop that in too? The moment of truth. Here goes nothing.
Frying tonight!
And holy moly, the stuff's coming off in clouds, like plumes of smoke underneath the liquid. It's hard to film, but I can see the baked-on soot bubbling off of the board, which is amazing. Some of the components on the board aren't meant to spend too long in an ultrasonic cleaner, for example the electrolytic capacitors. The guidelines from Panasonic say no longer than 2 minutes, but if they don't work we're going to replace them anyway. Another concern I had was the frequency generating and frequency sensitive X-Towels, the crystals, but because these are in the megahertz range they should be fine. And that's the first pass finished, so let's see how that's come out. Blymos, what a transformation already. That's literally unbelievable because I don't believe it. As good as it's starting to look, there's still some contaminants on the board, particularly around where the white labels are. So whilst I'm aware there's a risk of going too far, let's flip all these items over and give them another session. As I mentioned before, ultrasonic cleaners use a phenomenon called cavitation. The ultrasonic waves literally rip the fluid apart. This creates microscopic vacuum-filled bubbles that then implode. This physical reaction creates friction and heat. In fact, up to 5000 degrees Kelvin. But because the bubbles are microscopic, the overall effect is only tiny, just moderately heating the fluid. But it is great at busting bonded dirt from hard surfaces. But like all good things, you can overdo it and cause something called cavitation erosion. This eats away at the surface, causing pitting. And by the end of the second session, I think we're done. And there's certainly enough crud at the bottom of the cleaning tank to suggest that our efforts haven't been in vain. That's actually disgusting. Off camera, I washed the boards down with fresh distilled water. The boards could do with a good buffing up, but the difference is genuinely shocking. I'm actually really pleased. For my first experience of ultrasonic cleaning, I think that these results are astonishing. Everything is as clean as a whistle, including the metal pins and connectors on the boards. Brilliant. The metal modulator lid is still really ugly, but it is clean and it is rust free, so that's a win. And hiding under the motherboard we find that EPROM. It's still a bit covered in gloop, but that is easily removed now. I do think this illustrates that some soft materials aren't really suitable for going in the ultrasonic cleaner. The legs on the EPROM look a lot better, but they could still benefit from going over with a fiberglass pencil. He slimed me. They do say in show business, leave people wanting more, and this is where I might disappoint a few of you. We're going to fire this up in the next video about this Amiga. We'll also try and use this Gotek. It was lost in the fire, so if I can get that working, it will be a big emotional win for me. But look, fixers, just look, the results are unbelievable. The ultrasonic cleaning has even started to take the markings off of some of the chips. Do you have an ultrasonic cleaner? And do you have any tips for me, and did I do anything wrong? If so, let me know in the comments section below. Massive amounts of love and gratitude to my patrons. They literally keep the channel going, and to be honest, without them, I'd be lost. It's easy to become a Patreon at patreon.com/markfixesstuff. Patrons receive ad-free early access to all my videos. They also get the inside track on what's happening at Mark Fixes Stuff, as well as access to the exclusive Discord channel. By the way, if you got this far, have you spotted the hidden clue about what we're going to do with this Amiga next? It might not have happened yet, or maybe it has happened. Or maybe it's going to happen right now. Who knows? Thanks for watching, fixers. And massive thanks to Elaine Hu for believing in this channel and 3D printing us a crystal clear Amiga case. That's right. It's on its way. See you all in the next episode, and thanks for watching. And as you got this far, why don't you watch one of my other videos? It's brilliant for my statistics and I'd really appreciate it. Do the clicky thing then.